Hey guys, how is everything going? I hope you're doing well. I'm safe. Please stay at home. Stay healthy. Let's take a look at number 91, Decode Ways. A message containing letters from A to Z is being coded to numbers using the index. A is 1, B is 2, Z is 26, and we're given a non-empty string containing only digits, determining the total number of ways to decode it. Input is 12, for example, so it might be 12 itself, which is L, or AB 1, 2, and 226, it might be 226. It's BZ VF 226 or BBF 226. It's like kind of pretty straightforward. We're getting like 226. We first get the first digits 2. It might be used as a standalone or combined, but it's the first index, so it's sorry, it would be used to stand as a standalone digit like 2 itself, and then we could just handle the rest, right? 26, and then or the next one is 2. We can treat as 2 as a whole and handle the rest a 6. So this leads us to a naive recursion solution, right? The idea is simple. For each digit, we check the next digit. If they are between 10 to 26, we need to do some conditional checking. For the rest, like 30 numbers above 26, there's only one possibility. So we don't need to worry about that. Okay, so let's so it's recursion. We create this walk method. Say check. Okay. The intermediate result would be the number of the ways. So I'll say count, and the next parameter would be the rest, right? We handle 22. The rest would be 6. We could passing the rest substring, but it will generate a new substring, so I'll just use the index to send for it. So we'll just start and find it. And so when this is done, we can just return check the count. Of course, count is 0, and the start would be 0. So let's do it. We get the character, right? Okay, start. Now let's check what's the possibility of this character. If check character, we switch character. If it's 0, okay, 0. There's no matching for 0, right? So we will just return 0. There's no possibility for 0. And for 1, we need to check the next digit, because if next digit is 0, then it must be 10. If it's not 0, there are 2 possibilities. Okay, so if s start plus 1 equals 0, then there is only one possibility as 10 combined. So we will return check count start plus 2. For the other cases, there will be 2 possibilities, 1 itself or 1x, right? So we check first, it's 1 itself, count start plus 1, plus check count start plus 2. This kind of like Fibonacci. Case 2, it will be the same. So check if it's 20. If s start plus 1 equals 0, Oh, it's not number, it should be string. We return check count start 2. For the other cases, well, for 2 it's a little special because the possible ranges for combined letters digits will be from 0 to 6. If it's bigger than 7, then it will be only one possibility. So if start plus 1 is bigger than 6, JavaScript will do the transformation by itself. If it's bigger than 6, there's only one possibility. So to 7, something like to 7, return check count start plus 1. For the other cases, there will be 2 possibilities, like 2 or 2x. Return check count start plus 1 plus check count start plus 2. For the defaults, well, default is the same, right? So for the other cases, it will be only one possibility. Yeah, for 3, because it's over 3, yeah. Return check count plus 1. Oh, start plus 1. Now we have a problem is that when will be done? When will be done? So we might jump 1 step ahead or 2 steps ahead. So the index might be than overflowed. So if the digit is last number, it's obviously is only one possibility, or it's over that last number. That's also if it surpasses the last digits, it will be also one possibility. So if start is bigger or equal to s.length as 1, then the possibility will be only 1. But if we do this, if actually the last number is 0, this will not be good, right? So I think we need to check here if character is 0, because you see, if we do something like this, it's for a valid input, it cannot generate extra zeros, so we can safely return 0 here and return this. Okay, so we run the code for 1, 2, it should return 2. Yeah, for 1, 2, 2, 6, it should return 3. Yes, let's submit, and by the same time we analyze the time and space complexity. For time, we're using recursion. For the best cases, you see, we only encounter problems as case here or here. So if nothing is special, everyone could be only as used as the standalone digit, it will be on, right? So the worst case is that every time we met two possibilities, then for that it would be fn would be Fibonacci, right? Well, because we want to know the worst case, so fn, let's just use 2. If we do the approximation, if we do it approximately, it would be 2 to something like this, right? So it would needs to to the power of n. So it's exponential. It's slow, as we can see. It's only faster than 13% of all the solutions. So for this kind of case, for any time we meet the not that good solutions with recursion, we might want to rewrite it into iteration with the dynamic programming. So we try to use dynamic programming. So how can we understand this problem? Now I'll just remove all the code. It's because they are not needed anymore. Let's take a look at the example again. For 2 to 6. For 2, okay. Let's say if we are done with all two solutions, now we add an extra digit, which is 6. So what will happen? So for 6, at most you will use 2 extra digits to create a combined like 26, right? So it will not affect the digits before these two. And depending on this number could be used as combined or standalone. We can actually derive a formula which will help us get the count of ways. I'm not sure I'm putting this right. I mean, for extra number 6, there is 2 possibilities, right? The first one, it will be used as a standalone or combined, right? If standalone, it will affect n-1, which means just use the previous result. If you combined, it will use use affect fn-2. All right. Yeah. Standalone. Yeah. So it's obviously, let's say, for fn, which is the length of this digit, fn, what it means? It means if we could use this as combined, if we use first, let's use it as standalone digits. If you standalone, it would be fn-1, right? Which will be the same because you use it as a standalone. Plus if you use it as a combine, it's like this. It will use fn-2. Right? If can, right? If can. So now it depends on conditions required. So if we say Sn is 0, what will change? If it's 0, then the previous one must be 1 or 2. If it's 1 or 2, then we can use Fn, right? So, and Sn-1 is 1 or 2, we use the combined, so f minus 2, or it should be 0. Yeah. If Sn is 1 to 6, and we can check Sn minus 1 is 1 or 2. We would say if they could either be used as standalone or combined. That would be f n minus 2 plus plus Sn minus 1. If we use this as combined, so the solution would be here. Wait a minute. There's a problem. Is that for case here, if we use this combined, we'll use fn minus 2. It's okay, but if we want to add to minus n minus 1 like this, it actually contains the solutions. It might contains the solutions. Because this one use I think it's right. For like this is 2. The conditions here, possibilities here are 2. If it's combined, it's 1 possibility. And now plus the possibility here. Combine. Standalone. Yeah. It's right. And then if Sn is 7, for the other ones, we need to check Sn. Wow, it's trivial. Sn minus 1. If it's 1, then it could be the same, like this. If not, then it must be used as a standalone, so like this. Okay. Let's just create a user array to store the intermediate results. Let's say result equals array s.length, field is 0, for let I equals 0, we need to, how can we handle the start of this problem? Wow. I think I need to shall we insert 2 empty numbers at the beginning? Like +2 extra. So for the first number, it will get 0, right? Fill with 1, I think. Yeah, nothing means 1 possibility. Fill with this 1, but remember, when we get the result, we needed +2 for the index. So to avoid problem, +2. Okay, const character equals si. Let's just follow what we wrote here. If character is 0 and if s I minus 1 is 1 or 2, 1, 2, if it's 1, 2, then it should be used as combined. So result index would be result index minus 2. Yeah. For the rest, it should be invalid, so it should be 0. Actually, we could just return 0. It's invalid. Okay, for the rest, if else if character is smaller than 7, if s I minus 1, so also if previous one is 1 or 2, there is 2 possibilities. So result index equals result index minus 1 plus result index minus 2. For the rest, there's only one possibility, so result index equals result index minus 1. For the other cases, else if s I minus 1 is 1, anything is possible. So this, and we could do this. Finally, we return result s minus 1 plus 2. I'm not sure. I'm really not sure I'm doing this right. Let's just run the code. Of course, there's a syntax error. It seems that we're doing it okay. Cool. Submit. Oh yay! We're accepted. Wow. I'm really not very confident about this one, but it turns out our approach is right. We did it with recursion, but it's bad because for the worst case, it will the time complexity is almost exponential. But now we're using dynamic programming. We cached all the results, and by analyzing the last 2 bits of the input, so now the time complexity would be, you see, for each digit we're using constant time to do the calculation, so it will be linear time. Well, it's improved very much. And space, we use an extra space to store the result. Yeah, it's O N. Actually, you see, for the most extreme case, we only check the last two results, right? So actually, this could be improved to use O3. Sorry, the recording seems broken. I'll just continue. So the space, we're using N, O, big O, N to store all the results, but actually we only need 3 of them. So this could be improved to, yeah, O2. But I'll skip the implementation. You can just do it by yourself. Like here, we could just initialize with 2 elements and use push and pop to set the result. Yeah, so that's all for this problem. Hope it helps. See you next time. Bye bye.